All right, let's finish section 4.7. Example 3 says graphing linear functions. A family of functions is a group of functions with similar characteristics. We're going to talk right now about linear functions. Eventually, we're going to talk about quadratic functions and exponential functions and logarithmic functions this year. But for now, we're just on linears, and I want you to notice that the parent function is this f of x is equal to x, or that line y equals x. Now we could create a table for this. It's a pretty basic table. For every x value that we choose, we would have the exact same y value. So that -1, 0, 1 will give us -1, 0, and 1. Or if we wanted to use slope-intercept form, which is probably the better way to graph nowadays. So a table is good. It's a good way to back up, test our points. But the best way is to think about this in slope-intercept form. So in this problem, the m value, or the slope, the number in front of x, is 1. And the b, the y-intercept, is 0. So we're going to start at 0 and have a slope of 1. Or all of my x values match my y values. Now the best part about this particular line is that you can just memorize it. It's the one that cuts us in half, cuts our coordinate plane. Mr. Descartes' coordinate plane gets cut in half. All of these points, all the way up to +10, +10, all the way back down to -10, -10. Now, if we have to graph the function g of x, so now we just named it differently. It's still a function, it's just named George instead of Frank. And it still has x's in it. It just means that x is the independent variable, such that x minus 2 will give us all of our y values. And then we have to compare it to the parent graph. Now the cool part is that they've actually already graphed this one for us. They started at -2, and they used a slope of +1, because that's our m and our b, c and g. The m value is 1, and the b value is -2. So they've graphed our points and connected our dots for us. They didn't put the parent function in because they think that you can see this, but when you have a tough one, you should definitely sketch in that parent graph. And how does it compare? It's been shifted down 2 units. It has the same slope. Notice that phrase there, same slope. And the y-intercept is 2 less than the parent graph. So you need to make those kinds of shifts. When they ask you to compare, things that you want to think about is using the word shifted. You want to think about using the word y-intercept. And you want to use the word slope. If you can work those 3 words into your comparison, you will have gotten all the pieces I'm looking for. So let's go ahead and practice. Graph the function m of x is equal to 1/3 x. So they named our function Molly. Molly has a slope of 1/3 and a b value of 0. And we're going to compare that to that parent graph. Alright, now I'm going to put my parent graph in green. Not very cleanly, but you should do yours nice and pretty. And I'm going to put my Molly function in a different color. Again, you're going to make sure your points are in nice and clean, and you're using your straight edge to sketch your lines. So now we're in that compare section. We've got our graph. So we need to use those 3 keywords. Talk to me about slope, use the word shifted, and use the word y-intercept. So in this case, I would say they have the same y-intercept, so there has been no shift. It hasn't gone up or down. The lines have the same y-intercept. They have not been shifted up, or the purple line, right? The purple line in my case, or the Molly function. That's probably a better way to say that. I think I'm going to say it the better way. M of x has not been shifted up or down. Wow, that's pretty sloppy. M of x has not been shifted up or down. Now the last thing we have to talk about is the slope. And this is where they're different. Notice that the slope, right, when we look at it, it's going up not as steep. 1/3 is less than 1. So the slope is less. The slope of M of x is less. Nothing fancy. See you in class.